So today we're going to talk about 9.2. We're going to talk about significance testing about a population proportion. Okay. So before we do that, let's kind of go ahead and quickly review what we did on 9.1. The most important thing about 9.1, so what was it? We had, if we were going to, so there is talking about, we talked about a null hypothesis and an alternative hypothesis, right? So the alternative hypothesis is actually what we suspect is going on, what we would like to prove, right? So this is what we hope is true. O is the opposite of that, or what is stated, right? Okay, so we are going to look to try to disprove the Ho and prove that we have evidence for the Ha. And the way we talked about doing that was to find a p-value, and we were going to compare that to the significance testing level, alpha, right? So hopefully we're going to find a p-value that is smaller than the significance testing value, right? And this is going to be like 1%, 5%, or 10%. And if it's not mentioned, we use 5%, right? So if the p-value is less than the alpha, then we were going to reject the Ho, which is what we want to do. We want to reject the Ho, and we can state that we have convincing evidence for the Ha, right? Okay. If for some reason our p-value was larger than the alpha, okay, then we do not accept the Ho. Remember, we cannot accept the Ho. We fail to reject. We fail to reject the Ho, and we do not have convincing evidence for the Ha. Okay? So in a nutshell, which is kind of what we learned in 9.1, right? Okay, so we look at the P, we're trying to find this, so we compare the P and the alphas, and we would like to have a small p-value so that we can reject the Ho and say we have convincing evidence for the Ha. Okay? So basically everything's all set up for us, right? The only thing that we do not know how to do here is to calculate the p-value, right? Because this is going to be given to us, right? And then once we find out, once we compare it, we know what to do with it. We just need to be able to find the p-value, right? So that's what we're going to talk about in today's lecture. So let's talk about that. Let's talk about how or what we do with the p-value. Okay? So let's go back to the free throw shooting guy. Okay? Remember we did the free throw shooting guy in 9.1. We said that the guy said that he has an 80%. He's an 80% free throw shooter. We give him the ball, and he shoots 32 out of 50 for a 64% free throw shooting rate. Okay. Yet he is saying that he is an 80% free throw shooter. Okay. So what we did in 9.1 is we actually did a simulation, right? We did a simulation to find out how often this happens, and we disproved this basically, right? Okay. So now we're going to actually calculate a p-value instead of using a simulation, okay? So first of all, just as so what's the Ho here? The Ho is what? The Ho is what he's stating, right? That his free throw shooting rate is 80%, and we are saying that no, you are less than 80%, right? Okay. So we need to be able to find the p-value and see what we can do here, right? Okay. So first of all, there are conditions that need to be met to calculate a p-value, right? Okay. And those conditions are the same as our confidence interval conditions, right? The confidence interval conditions were what? We had three conditions that needed to be made, satisfied. One was a random sample. Two was that you cannot oversample and we had the large counts, which was NP is greater than 10, and 1 minus P is also greater than or equal to 10, right? So you had large counts. So these three things, okay, these three things are still the same when it comes to significance testing, okay? So those three things have to be said. So let's go to our actual thing, right? So when we did this, when we did a confidence interval, what do we find? We found what? We need to find the test statistic, right? We need to find what? We have this guy, right? What was this guy? This guy was what? This guy was P hat 1 minus P hat over N, right? So we can calculate this for here, right? What is that here? That guy is 50. We're going to have 0.64 and times 1 minus 0.64. The square root of that, right? And if we do that, what do we get? We get... No, wait a minute. No. Okay. So, restart this. So, the actual proposed is what the P is what we're going to go over with here, right? This was P hat. Okay, this was P hat, right? And we said that we learned that the standard deviation of P hat is going to be P, which is actually going to use the P here, 0.8 times 1 minus 0.8 over 50, right? And if we do that, we get what? 0.0566. 0.0566. Okay? So you get 0.0566. That is the standard deviation, okay? So then we have to find out the statistics. How far away is this statistics, right? So we have 0.8, and we're going to have 0.64 here, right? So we need to find the z-score for this, right? The z-score, how far away is it, right? The z-score, so the z-score was what? The z-score was this guy, 0.64 minus 0.8, how far away it is, divided by the standard deviation. And the standard deviation here, we calculated right here, 0.0566. Okay, and if we do that, we're going to get negative 2.83. Negative 2.83. So in other words, this is negative 2.83 standard deviations away from the 0.8. Okay? So since this is now a normal distribution, now we can find out what percentage is this right here, right? And all that does is, just looking up your table D, right? Looking at your table D. If you look at your table A, I'm sorry, your table A. If you look up the table A, it says that it is what? It is, table A gives you 0.0023. 0.0023. In other words, there's a 0.2, this is 0.23%. So that is your actual p-value. So you've actually calculated the p-value, right? Another way to do this is what? Another way to find the 0.0023 is that we can use the norm CDF, right? You're going to do the normal distribution, cumulative distribution, right? So we're going to go from all the way over here, we'll say, we'll just call it 0, and then to 0.64, where a 0.8 is the mu, and the standard deviation was this guy, right? 0.0566. And if you do that, you'll get the same that, I think. You know what they're saying? Where are we at? No, this is standardized. I'm sorry. This is standardized. So we're doing the standard. Their book is doing the standardized. So if you do the standardized, right, we're going to go what? We're going to go from 0 or actually from negative 100 to negative 2.83, right, all the way from 2.83. Now this is standardized, so this would be 0, and your standard deviation would be 1. Okay, and if you do that, you get that. Okay, and that is actually after you know this thing here, right? Okay, so you'll have to know that to do that. Okay, so that's how you go about doing that. And now, so what do we do? So what are we going to do? We're going to actually find that the p-value is 0.23%. We're going to compare the p-value to the alpha. Alpha was 5%. So since the p-value is less than the alpha, we reject the ho, and we have convincing evidence for the ha, which means that we have convincing evidence that the guy is actually a less than 80% free throw shooter, right? Okay. So if you go to page 570, there's a definition there about the standardized test statistic. Okay, and the standardized test statistic here is this guy right here. This is our standardized test statistic. Okay. Okay, so let's see if we can do the example associated with the part-time jobs. Let's see if we can do that. So this is on page 571. In the preceding example, an administrator at a local high school decided to perform a test at the alpha is equal to 0.05 significance level of ho. P is equal to 0.25 and ha. P is less than 0.25, where P is the true proportion of all students at the school who have a part-time job. Okay? He selected a random sample of 200 students from the school and finds that 39 of them have a part-time job. Okay? We already confirmed that the conditions for performing a significance test are met. So that's actually, we did that, they did that in the previous example. So let's go and do that also, since we skipped that one. So let's see if we can do that. Okay, so let's look at our conditions. Is it a random sample? Yes. He said that they did a random sample of 200 students, right? And it said it was a large high school, and the N was 200, so we're going to assume that there were more than 2,000 students in that high school. And then this guy here, okay, the P was what? The P was 0.25, so this would be 200 times 0.25, which is actually 50, so this is greater than or equal to 10, times 0.75, the 1 minus P is going to be equal to 150, so that also is greater than 10. Okay, so yes, all the conditions have been met, so we're satisfied with that. A, explain why the sample results gives us some evidence for the alternative hypothesis. Okay, so we got 39 out of 200, which is what? This is going to be 19.5%, okay? 19.5%. So we have some evidence already that it is less than 25%, okay? B, calculate the standardized test statistics and p-value. So if I want to find the test statistic, what am I going to do? I need to find this guy first. This guy was what? 0.25 times 1 minus that, so 0.75 divided by n is equal to 200. And if we do that, what do we get? We are going to, they don't do that first. Okay, so this is that. This is that, okay? So we don't know what that is yet. The test statistics is what? The test statistic is this guy, so it's going to be 0.195 minus the actual, the whole is what? P is equal to 0.25, right? So it's going to be minus 0.25 over this guy, right? The square root of 0.25 times 0.75 over 200. And if you do that, you are going to get negative 1.80. Okay, so this is your actual test statistic. So to calculate the p-value, you would go p is norm CDF negative 100 to negative 1.801. That would give you your p-value. And if you do that, what do you get? 0.0359. 0.0359. In other words, you're going to get 3.59%. 3.59%, right? So if I had, so I was going to get p-value is 3.59%. So it's kind of interesting here, right? So if you did a significance testing of 10%, your p is going to be less than alpha. If you did a 5%, p is still going to be less than alpha. But if you did 1%, p-value would be actually greater than alpha, okay? So it depends on how tightly you're defining this, right? Okay, so since we're going to be using here a 0.55%, p is going to be less than alpha, which means that we reject the HO, which says that the probability of having a part-time job is 25%, and we have convincing evidence for the HA. We have convincing evidence for your HA would have been here, what? Your HA would have been P is less than 25%, right? So that would have been, you'd have convincing evidence that yes, they're less than 25%. Okay, so that's how you would go about doing that. And we'll call it a day today.